Alright guys, we're going to finish out here with a couple other constructs, which are going to be menus, and then some redirection we can do. So we're going to take a look at this menu example here. There's a lot going on here. To make it a little bit easier, I went ahead and wrote up the script ahead of time. So we're going to pull it up and kind of show you what's going on. So guys, PS3 is actually your terminal, okay? So it's one of the outputs of your terminal, okay? So we're setting that variable equal to terminal, question mark, okay? So you might be a little bit confused. So we're not actually setting a variable equal to terminal. We're setting the terminal equal to an echo statement, which is what's currently on here. And you're going to see what that means here in a second. Before we do that, we're going to look at a select term here. So what this actually does is it has you select a statement here. So real quick, I want to point out, in our example, we have these different phrases here. For your time and our time, and just to make things a little bit easier, I just made it A, B, C, and D, okay? Just so we can kind of have a little bit easier time to see what's going on. So we have select term in A, B, C, D, and A. So when we use select term, or the select statement, we have to give it a term, and we have to say in, and then we have to give the terms here. Actually, I need to make sure this says D. There we go. There we go. A, B, C, D, E. Okay. And then we end it with a semicolon and say do if term, and guys, do you remember what n equals, dash n? Well, it's not null. It means if anything is given to term. So if any value is put in the term variable, okay, which in this case is right here, right? So the select statement is taking user input and storing it in this variable here, whatever we want to name it. In this case, we're naming it term. Okay, so whatever they pick here, it's going to get stored in this. So if anything is stored in the variable term, then we're setting a new variable here. In this case, we are setting a variable. This time it's all caps, term is equal to the variable term. We're going to print term is term, okay? So we're using the word term a lot here, so try to really pay attention to what's going on. So print is analogous to echo, guys. So we're printing term is variable term to the screen. So that's going to get printed to the screen. We're going to export the variable term, okay? And then it's going to break this if statement, else print invalid. So if they don't print any of these terms here, it's going to print, hey, that's invalid. You didn't pick anything that was correct, okay? So let's see that in action so you can kind of understand maybe a little bit better of what actually happens. So we're going to do /menu.sh. Okay? Okay, see, so it's making more sense here. So PS3, this is the terminal here that we're looking at. So we actually said make the terminal equal to this question. Terminal question mark, which we saw. Now it wants us to pick something. I'm going to do A. Now what's going to happen here, guys, is I didn't set up anything. So when I type in A here, I would actually need to set something up to happen after you pick one of these options. Okay? In this case, I didn't. Now, see what happens if I do like G? Okay, no such file, invalid, right? So I'm going to cancel out this. So that's kind of how we create a menu here, right? So we're creating a menu here. This can be really nice. So this can actually be very handy script if we want users to do something. And we can get really fancy with this. So we can say, you know, if they pick A, then do this. If they pick B, then do this. If they pick C, then do this. And we can set up a lot of options. And inside of A, we can even create a whole nother menu. We can say if A, you know, then, and then we set up another menu and have all these other options. You could get a really big menu script set up here and have all these options set up for users to pick and have different scenarios execute based off of what the user picked, okay? So let's look at the spacing here because that's important. So we set a variable here. That's in line with our select statement here. We have our select statement. Inside of that select statement, we have an if statement. Now, inside of that if statement, we have some commands executing, okay? But remember, when we do if statements, else always gets lined up with the if, okay? And then after else, we indent. And then we want to finish this statement, so it's lined up with the else and the if. But we want to finish our select statement, so we did done, which is in line with the select, right? So guys, spacing is really important here, and this is called nesting. So this if statement here, you see that here, this if statement is nested inside of this select statement. And that's why these two are lined up and why the if statement is lined up here. And this is nested inside the if statement, right? This is all the commands we're going to run for this if statement. So this is called nesting. So the best way to really look at this is every time you nest something, you want to make sure it's lined up correctly. So this if statement is nested inside of the select statement. So we want to keep the if statement all lined up. And remember, the commands are always indented inside of the if statement. Else always goes to if. Phi always lines up with else and if. Okay. Variables are always just on the leftmost part of the screen, right? Those are going to be lined up on the beginning here. Okay. I could even, inside of this, I could even do another if statement, right? I could nest a if statement inside of here. I could say like if, variable a dash greater than etc., right? But I would have to nest it inside of it, so I'd have to indent it here, okay? That's all I'm getting at, is that when you nest something inside of it, or you want it to go to the next part, you have to put it and indent it from the other one, okay? So this is cool. This is how you can set up a menu that's interactive for users. Let's go to our PowerPoint. Let's look at the last construct we're going to look at today, which is redirections and loops, okay? Again, I kind of wrote this up ahead of time just so it was a little bit easier to read and you guys can see what's going on. So I just named it redirect.sh, and we're going to take a look at it. So before I start explaining these lines, this is what I want you to know that this script is doing. This script is looking at files in a directory, old files, and it's creating a new directory and archiving the files in that directory, okay? So that's what this script is doing. So let's look at that. So we have a variable here called archive NR. We're setting that equal to the date command, and we're setting it up year, month, day. Now guys, these aren't quotation marks here. These are back ticks. And remember, that's located above the tag key. And what this does is this actually uses command substitution. So it's actually going to run this date command with these arguments on it, year, month, day. Okay. Now I have another variable set up here, which is dest directory equals. Add the pwd variable, which is a set environment variable. And I'm setting equal to / archive dash and then the archive and r variable, which we have set up here, right? So the date command is going to run. It's going to store that in this variable, and then that variable value is going to appear here. Next, we're having it make a directory called dest directory. Okay, and where is this value coming from? Well, it's coming from right here, right? So it's going to take the primary working directory, so the current directory you're in, and then it's going to name it that. So the primary or the current directory you're in / the archive dash and then the date here, okay? Then it's going to find all files starting at, so the find command, you have to put where you want to start looking. Okay, so this is a command used in Linux. Actually, let me show you that real quick. So the find command is used in Linux. I can say find all files starting at / or root directory. Okay, I can say dash type of file or dash type, and I can say file. I can say like all, and then I can even say dash name and say like Kevin.txt. Okay, so that's kind of how the find command works. Is you have to start with where you're looking at, so a starting point, and then you start putting in the arguments and flags. Okay, so here's kind of a little bit more to that find command. See if I can, oops, too much. So that's kind of the everything that's listed with the find command. So I just wanted to show you that so you can kind of understand where this next part's coming in. So this is a command, so find command starting at our primary working directory or our current directory. The type is going to be file. We're going to look at all files. we're going to look at the last edit time. That's what this is, -m time. So the last time was edit. We're going to say 5 months back. Okay? And we're going to pipe that into a while statement. So while read -d. Okay? We have another variable here. So we're catching any files with spaces in them. We're saying do so we're going to gzip the file variable, and we're going to move it to file.gz to the destination directory variable, which is going to be this, right? So all we're doing right here is we're gzipping the file, which we just found, or files that we just found, and we're moving them, or in this case, we're just renaming them and moving them to the new directory that we created up here. And then we're going to echo the file name was archived, okay? A lot going on there. Let's see what happens. So we're going to make that executable. Okay. And now we're going to run it. /redirect.sh. Oops, did I spell it wrong? There we go. Okay, so if I do an ls now, you see I have an archive directory, right? So it took that date command and it put and filled in that part there, right, which we saw in our script. It ran the date command. Oops. So it took the date command and it filled it in here. That's this part, right? It stored it in the current directory. So if I go back here, we're looking at this directory. So we have the date here. For me, it's the 19th of September, 2020. It stored it in my current directory and named it archive. Okay, now if I go to that directory, I shouldn't have any files in it because I don't really have any files that are that old. Yeah, there's no files in there because I don't have any files that date back 5 months. Okay. Oops, did not mean to do that. Oops. Back one. There you go. So that's what that file did. Alright, there was a lot going on there, guys. I know that. But what I wanted you to see is how useful these scripts can be. How we can use multiple things in it. We can even pipe the find command into this while loop. Okay, so we redirected the output of this find command. It found files, and it put it in this while loop. And all those files that were found were ran through this while loop. So it found the first file, it gzipped it, named it, threw it in that directory archive that we made. It found another file, zipped it, threw it in the archive directory we made, and so on until it doesn't find any files, and then it finishes. Okay, that's exactly what happened. In this case, it made the archive directory, but it just didn't find any files that were old enough for me. Okay, so let's finish out our PowerPoint here. Let's talk about when to use different constructs. So the corn and bash shells are very similar, but there are some differences. The shebang line is the very first line of the script and lets the kernel know what shell will be interpreting the lines in the script. Now guys, you've heard me call this shebang hash spling, okay? Those terms are interchangeable. The hash spling and shebang are the same thing. But as you see here, it tells the script what shell it's going to be using to interpret the script. So it is really important that you put the right shebang. The shebang line consists of a hashtag or pound sign and then an exclamation point followed by the full path name to the shell. So you see me put bin bash here, just like this one. You can also do corn shell. Local variables are in scope for the current shell. When a script ends, they are no longer available. So For example, when they go out of scope, local variables can also be defined with the built-in declare function. Local variables are set and assigned values. So this means when a script runs, any variables that were inside of it immediately terminate when the script is done running. They don't last or stay around. Okay, and that's important to know. So guys, we went over conditional expressions, testing strings, testing options, numeric conditions, testing completion status, truth and corn and bash cells, the case statement, loops, while and until, the for loop, menus and the select statement, redirection and loops, and when to use different constructs. Next session, we're going to go over redirection review, opening additional streams, redirection operators, inheriting and duplicating streams, caution with the exec command, and here documents. Guys, if you need a little bit of extra help, be sure to follow these links to the private tutoring sessions for system administrator management. There are weekly and monthly plans available, as well as Linux and Bash scripting private tutoring sessions. Thanks so much for joining me, guys. I'm looking forward to seeing you in our next session as we continue along with this course.